operations. What exactly is the difference between conventional milling and climb milling? Let us start with conventional milling, which is used more frequently. In conventional milling, the cutter rotation direction is opposite to the workpiece feed direction. When the cutter first contacts the workpiece, the cutting engagement is very light. As the cut progresses, when the cutter is about to exit the material, the cutting force gradually increases. This alternating light and heavy cutting force is most likely to cause vibration in the workpiece. As the vibration continues, circular ripple-like marks appear on the surface. These are what we commonly call chatting marks. In addition, before the cutting edge fully engages, it rubs across the surface first, pushing the material upward. That's why surfaces produced by conventional milling are often relatively rough. However, conventional milling does have its advantages. For example, when a material has a hardened surface layer, conventional milling can scrape off that hard skin first. If you are aiming for better surface finish and dimensional accuracy, then climb milling is the better choice. Climb milling works in the opposite way. The cutter rotation direction is the same as the workpiece feed direction. As soon as the cutter engages, it cuts at full chip load. The initial cut is heavy. As the cut continues, the cutting force actually decreases. When the cutter is about to leave the workpiece, it smoothly slides along the machined surface. As a result, surfaces produced by climb milling are smoother and more precise. However, climb milling has a prerequisite. The machine tool must have minimal backlash in the feed system. If the backlash is too large, the cutter may suddenly grab the material. In severe cases, it can cause tool breakage. Conventional milling and climb milling can occur at the same time. For example, when milling a slot, on the right side of the cutter, the rotation direction is opposite to the workpiece feed direction, while on the left side, the directions are the same, which is climb milling. The cutting forces on both sides offset each other, making the machining process more stable. As a result, the end surface finish is improved. Now do you understand the difference between conventional milling and climb milling?